Hello, everybody. Hopefully this works. I'm still not totally confident in this Zoom thing, but we'll give it worked last time, so hopefully it'll work this time. Okay, this is the first kind of our theory or informational videos about human factors. If you're have a human factors background, a lot of this will probably be old hat, so we'll probably the next couple of weeks. But it's important to revisit it, and especially for those of us that aren't familiar with it or haven't done it in a while or anything like that. It's good to take that time and just explore it. This will be essentially an introduction to human factors concepts, the different disciplines we involve ourselves with, some nuclear specific areas. It's kind of just going to feel scattershot. So, um, and the slides are this slide deck is kind of adapted from a few different presentations. So if the style is not super consistent, so sorry about that. But hopefully it's valuable and answers some questions. And then after this, go on the Slack, maybe make a post about further questions you have after this. If I brought up something that you're not sure about or that you disagree with or that you have a different approach for, post something about that, and then we can kind of start a conversation as a group and kind of go over some of those concepts. I know I've received some questions already about um, things like, hey, are we going to do a task analysis? Are we going to explore what some of those concepts are? And we'll cover a little bit about that here, and then and hopefully, as we go forward. The benefit of this course is we have some flexibility. So if there is some topics that you guys are really interested in, human factors in a specific field or any of those things, we can totally dig into that. So let me get the slides up here. And okay, so here is our intro. Should be good. Let's see if, let's hope that this captures. It should. Okay, so here's our human factors intro. Okay, so human factors / ergonomics. So one thing that occasionally you will see is there will be I remember here at the INO actually it came up once that somebody was of the impression that human factors was just ergonomics, which was funny because I said, well, if that's the case, we have a department of about 10 or so cognitive psychologists that might have some questions about what they do all day because we don't do ergonomics much. But essentially, human factors is a field is the study of humans interacting with technology, or if the technology seems overly restrictive, in my opinion, human factors is the study of interacting with stuff. It is how we navigate our world. I think there's human factors challenges and aspects of it everywhere. One of my favorite quotes from a show is from the season 1 of Fargo, where Billy Bob Thornton is getting released from the police. He's a hitman who's been arrested and has this side identity cooked up that works. And one of the police officers, asks, I believe he asks, "What are you?" or something along those lines. And Billy Bob says, the human eye can see more shades of green than any other color. When you know the answer to why that is, you'll understand. Um, which is interesting to me because that's, nature or our bodies maybe internalized a design of nature for survival. The reason we can see more shades of green is to differentiate in the wild predators. So um, it's just an interesting way to think about the world. And in my experience, I don't know if the other human factors experienced folks in the group will agree. Once you've kind of started to see these things, you will never not see them, which is interesting and also incredibly frustrating as you go through life. So as we're going through here, that second point on here, the study of designing technologies to optimize human performance, that is that's our focus in this course. So it's human-centered design in nuclear systems. So we're going to be focusing on, okay, how do we design this in a way that maximizes human capabilities? Um, and then this cartoon on the right there, on the right bottom, is a very common one you'll see. I don't know what the correlation was with the Olympics, but they said human factors is above the neck, ergonomics is below the neck. Okay, I guess to me, human factors is a discipline which ergonomics fits under, with many other angles of it. But however, makes sense to look at it. Ergonomics is primarily concerned with the study of how to design system to maximize physical human performance. So it is more concerned with, the physical laws of our body and how we work, whether it's strength, endurance, flexibility, those kind of things. And it's related at the bottom there to anthropometrics, which is, the measures of the human body, measures of human capabilities in those ways. So, um, and I totally full disclosure, if you ergonomics really seems like your bag, there is an ergonomics course offered from the psych department. I believe Dr. Cohen's still doing that. And it's a great course. I personally, human or ergonomics is just not my bag. So it's not something that I'm super interested in, but we can still talk about it if it's an interest for you. Okay, now we're going to go into the history of human factors and ergonomics. It's relatively new, in the grand scheme of things. We start with the industrial revolutions. Now, this isn't to say that human factors, the idea of human performance only started, a couple hundred years ago. Not really, but prior to the industrial revolution, work and the just experiences of living was very singular or focused, I would say. If you were a tradesman or a craftsman in the 1500s, let's say you were a cooper, you were making barrels, you didn't have to deal with the overall design of the task. It was more goal directed, goal oriented to create the barrel. With industrial revolutions, and like this calls to note the Bessemer process, with these improvements to how we do work, we found that efficiency dictated singular tasks. The line cook style structure of teams. And similarly, it was kind of the first moving assembly line in 1913, probably one of the biggest technological improvements of human history, enabled mass production. So then the idea of efficiency coupled with time and that end goal of production quotas and quantities became really important, which then meant, okay, we can't, we have to make sure that our workers can do this job and can do it to the best of their ability, so we make the most money. Some of the foundational work in human factors, Fred Taylor and the Gilbreths, they were a couple who worked on time and motion and fatigue studies. So a specific thing to think about are the Gilbreths worked on, and Taylor somewhat too, on what they call basic actions. So they believe that all human action could be broken down into key steps. So think if you are going to pick up a cup, you have to, there's a reaching motion, a clasping motion, lifting, those kind of things. Those individual basic actions, which they defined a set of them, are, okay, that composes all human actions. So if we measure enough of these, we can predict how much time it will take to do any human action. And the goal was, productivity and efficiency increases and reduction of fatigue and injuries and all those things. And here's some more of their kind of the details of their work. So the time study, average times for average workers. They would measure distance the specific motions, those are those basic tasks, and the amount of work completed in order to kind of validate this theory that they had. Now, as we go into the early 20th century, um, World War One brought about the kind of birth of aviation design. So, design of aviation psychology and different medical, biological considerations of flight. But prior to World War Two, we were still essentially building machines and putting the person in them. And as we were constructing that machine, we put very little thought or effort into what the human may want to do. Um, this now in World War II, this kind of had to be adjusted. They started to fit machines and designs to humans. Specifically, this is the B-17, which is one of the biggest, I guess, what would you call it? Practical or what natural consequences of poor design. So essentially, the problem was, as you see there, you have two levers. These levers were down on the right of the seat, if I remember correctly. They might have been between the pilot's legs. And the problem was they lost a couple hundred planes during that year, and they didn't understand why. They have highly trained pilots. They have procedures. These guys know what they're doing. And the problem was they were pulling up their landing gear as they were trying to land the plane when they thought they were actually putting their wings down to help slow the plane and drop. But because they were not able to differentiate the levers and they couldn't see them, they mixed that up pretty regularly. And no amount of training or proceduralization was helping to correct it. This led to, and I'll go back, the Alphonse Chaffness, he was one of the people that worked on this and on shape coding. So his idea was to design the levers with a shape in mind so that they could differentiate them and they were associated with what the lever would do. So these are some examples. You've got the wing flap lever, they're shaped like a wing. And then you have the landing gear that is shaped like a tire to kind of get that through to them. This then spurred into some of these shape coding testing. So how accurate are we at deciphering shapes by touch and differentiating those? We're very good at it, by the way. So these are some of those knobs, and as they designed them, once that worked for those first two levers, they started to adapt that to a lot of different things. It's interesting because if you look at some of the control designs from this time period, it almost resembles like what we would think of like a kid's toy now, where they over design the steering wheels or whatever in order to give kids, just make it more interesting. And that kind of resulted in this idea where we design for the user. It's not enough just to design something. You have to identify the user and consider their respective abilities, needs, and limitations. So modern human factors in ergonomics, it became more and more prevalent over the years. Its links with some of the productive work from the Gilbreth and Fred Taylor on maximization of human workers caught a lot of interest. And also in nuclear, it became very, very prominent in the 60s, 70s, and eventually in the 80s with the 3 Mile Island disaster. In aeronautics, the complexity of these systems spikes, so the need for more complex users increased as well. Now, since the 1960s, there's been significant jumps in other disciplines and just a lot of breadth work, I would say, in human factors, where we have had to apply those notions to a lot of different things as different technologies or tasks or situations became more ubiquitous in our life. This calls out the space program. The space program has been, and NASA have been humongous players in the human factors world for a long, long, long time. And we're kind of at that again now with long duration space flight being something that they're looking at. Those are involve other human factors and ergonomic considerations. And the bottom there's safety critical human factors. So this is where we're getting at the 3 Mile Island issues and things in Chernobyl. And okay, how do we design these very complex systems in a way that maximize human capabilities? I like this because it shows, and that top list of 6 bullets is not at all exhaustive. There's a ton of different names and titles and different things. Some people put safety in human factors. It can really be it's almost to build your own adventure in that sense. The biggest focus though is whatever you're doing, it has to be done with the user in mind and the user as the primary guiding mechanism or measuring stick. That is a key component for that. And if you have an interest in publishing any of these, the Human Factors and Ergonomics Society has an annual conference and some journals. There's also the Applied Human Factors and Ergonomics Conference. That bottom one, SIGCHI puts out the CHI conference, which is the premier kind of place for emerging human factor or human computer interaction research. It's honestly, it's more has a higher effect size or impact factor than a lot of other journals. So that's a really great conference to look at the proceedings if you're interested in the HCI and kind of that bleeding edge. So what are the human factors? Again, not exhaustive. I think anybody can probably come up with a couple of extra ones, but these are the most common ones that you will see and capture, I would say 80 to 90% of the things that affect us as we navigate life. Each of these has a key role to play in any design task you do. And sometimes what you'll find as you undergo a project is some departments or organizations or managers may have some reticence to some of these. Especially the organizational factors. It's an interesting thing when you go in to look at a failure or an event or try to help somebody, make something better. And you find out that the organization is the problem. That's kind of hard when the organization's also paying your bills. So it's important in human factors, though, to just keep in mind that if you're not advocating for the user, you're not doing your job. And that's kind of the most important side of this, is to make sure that we're keeping the user in mind, either for safety or for just ethical design is something that we will get into later in the course. Accessibility is a big one too that's coming up now. So just keep these in mind. So human factors in general, when it's applied correctly and there's ownership in those groups, it'll improve safety, productivity, and performance. Your training needs will go down. Any of your maintenance or user help will go down significantly. Your errors and your costs associated with those errors will drop. And you can just improve your system design overall. So while initial cost, that's what this is showing here, initial cost of human factors, projects or undertakings can be significant seeming. Over time, they pay pretty substantial dividends. Now, nuclear. These are some very nuclear specific characteristics here. And these are essentially regulatory expectations and just kind of how it works, whether you're at a power plant or you're at a nuclear facility, like a research facility, like some of the ones we have here at INL, or you're in a lab that has nuclear material. These should be present in every case of that, because one industrial hygienist once told me, you can't, we can't get the radiation out of you once it's in. So it's important to just make sure it never gets in. Um, so training is a huge, huge part of the nuclear world. When you're getting licensed to operate a nuclear power plant, that is a license from the NRC, and it is a very involved process. And they also have continuing training. Every year they have a certain number of hours they have to spend in a simulator where they have to be able to navigate various abnormal situations. Procedures are also a thing that you will see there. That's why I think I said this in the intro to the course of nuclear experience preferred, not necessarily, because you can get kind of and anybody who has some experience with people in the military can see this too. You can get brainwashed isn't the right term, but essentially you can get to a point where procedures are kind of your default. And if you don't have them, you feel lost. We're operating outside of that box, but be aware that in nuclear, whatever you do, you will have to have a procedure for probably. Three-way communication. This is a huge one when you see operators actually doing tasks where one will say open valve, X to 20%. The other operator will say opening valve X to 20%, valve open to 20%. The original person will say confirmed valve open to 20%. It's that three-step process to make sure that there's total understanding. If you ever get the chance, it is really neat to see it in action with people who know what they're doing and can have done it a lot. It's really, really cool. Use the two-person rule, second checkers, proper supervision. This is some of the ownership of, we know human errors will happen. It's less likely that two people will make an error versus just one. And at any given moment, we need to minimize operator workload. I like this one because it's interesting with that. These are some kind of general principles. One thing you'll notice as we go through the course, all of your general principles have probably as many exceptions as they do rules. So I agree with this. Controls should not look the same, and they should be associated with what they're controlling. So they should be nearby or have some other link. Not always. It essentially depends on your design. When we think about computational design or HCI stuff, human computer interaction is HCI. If we think about web design or app design, that's not always true. Association in digital design is quite a bit different, especially in the last 5 to 10 years. So if you have a good reason to deviate and you have evidence, user testing evidence that it's not going to tank your design and make it unusable, then it's not necessarily that you have to do these things. So keep that in mind. But by default, especially in an area like nuclear, these are also expectations that will be there for your operators. So important to try to maintain that consistency if possible. This shows an example of bad design, but it's essentially the same thing with the plane levers. So two levers identical, it's impossible to differentiate them. So you put something at the top that they can differentiate the difference. You can label things, but graphical associations by visualizations work, like graphs and charts and things. Our visual system processes things faster. So it can be a benefit for that. So now looking into kind of process control specifics and some of those methods and human factors that relate to that. So process control is a very big field. Nuclear counts in there. So does any kind of manufacturing at all. Process control tends to be focused on like common good style services. So power generation, raw material collection or refining, those kind of things. But it really can be anything that is just a large complex process. and you are trying to control it in some way. You're trying to maximize it, decrease it, maintain it, whatever, in that instance. So process control as a whole in human factors doesn't get a ton of time, I would say, or a ton of focus. And the reason for that is, I mean, these are some of the reasons. You know, there's more jobs in consumer human factors, because you can, if you design something really, really great, you'll make a lot of money. And if people like it, people don't really think about what happens when they flip the switch in their house and turn on the light. It can be considered boring. It's slow paced and there's no innovation. The no innovation thing, not true, but totally understandable why you would have that assumption, because it is slow, and any innovation you do want to make, even if it is the most common sense and everybody agrees, it's still going to take a significant amount of time and effort, and you have to triple check your results and really prove it, where that bar is significantly lower if you're designing a new application for a phone, for example. The heavy regulation and difficult to make a difference. That is part of why innovation is difficult. It'll take 10 years before anything I do takes effect. Yeah, probably. But that effect is more substantial, probably, across the whole of humanity, I guess, and those kind of things. This fourth one here is true. It is hard. It's not just enough to know human factors. You have to understand industries, operational requirements, regulations, and some of the engineering background. You have to kind of understand how these systems work, which can be a huge hurdle for a lot of people. And how can you pull this off in a classroom setting? I don't know. That's what we're trying here. We'll see. Now, these are the reasons we should study process control. So I already covered some of these. It's safety critical. If those designs are bad and people make mistakes, it's not just a company goes bankrupt and some people lose their jobs. That will probably happen. But on top of that, there may be damage to the environment. People can die. Huge, huge effects in those fields. And it is, you know, we already talked about that it matters and it impacts all of us, but it's also a high level of specialization. So it's really interesting work if you can tolerate the pace of it. And there is a lot of work to be done, is what I would say. And this is where we're going next. So when I say there's a lot of work to be done, you'll see this. Let me say what's wrong with this picture. There's a lot of things. I mean, it's kind of open-ended. So to me, too many alarms are actuating. So those are those lights at the very top of those bays, or what they're called. They're called bays when they're just a big section of controls. Notice that it's all analog. This definitely looks like a, you know, what we would see as an old power plant, you know, on a movie or a TV show. But keep in mind, they all still look like this. Lots of paper around. That's another thing, you know, that I would be concerned about. So you can kind of just take a look at this and pick out what you think and what bothers you about this picture. So here's some example of important work that takes a long time and is really hard to innovate, but kind of needs to get done. Is human factors has a big role in control room upgrades. So the United States has 90. I can never keep it straight because the plants unfortunately close at a somewhat regular pace, but 90 some odd nuclear facilities in the United States that generate power. Nuclear power, if I remember correctly, generates 20% of the US power. In Europe, it can be significantly more than that. There are a few European countries that their primary export is power because of nuclear. But here in the US, we have a lot of these facilities are old, greater than 40, 50 years old, and have similar control systems as to when they started. They have not upgraded into digital. There is not a digital control room in a nuclear plant that is generating power in the United States at all. And the problems about doing upgrades, costs associated. It is very, very expensive to build these computerized systems for a bespoke plant, because that's the other thing to keep in mind in nuclear. Every single plant is different than every other one in some fundamental ways. Regulations make it very difficult. If you're going to do any change to a system that could impact safety, there is a pretty lengthy and exhaustive review process. So a lot of vendors are just keeping that running. You know, they know how to make those control systems, so they just keep making them. And then if you're not making a significant change, you don't have to go through the regulation headache, which has led to piecemeal replacements instead of systematic upgrades. So instead of upgrading your control room, you may change one function in the system, or you might add in some other things. And right now, there's just not a lot of human factors experience across the industry that can really leverage it and make it effective, and try to defray some of those costs, and give some assurances, I guess, to those regulators that we are doing it in a safe way. Modernization is what you'll hear. You hear control room modernization. Doesn't necessarily mean a new control room completely. It can mean a lot of different improvements. And so this is just a graph here that just shows different ideas. So behind the board's modernization, on that bottom right, for example, is a back end situation. So maybe you keep the boards all the same, but on the back end, you fully digitize the data collection. On the top right is what we would consider a full modernization. This is a good example here to just show. This was a survey conducted with, I believe, yeah, it says right there, 11 US utilities and 10 nuclear installations almost 10 years ago about the hurdles for control room modernization. This is what they listed, and what they would likely do. So we're seeing, you know, a significant amount of piecemeal approaches. Also, I apologize, for some weird reason, we can't, or at least I couldn't find in the report where it was colorized, these pie charts. Pie charts are notably bad anyway, especially when you make them monochrome. So that's something there that, again, even in this course slides, bad design is everywhere. Some requirements for human factors to function. You have to have a platform, a design, and an evaluation mechanism. And we'll go through that as we kind of keep going. Human performance. So this is kind of just in general, human performance. So cognition is a big aspect of human performance. How do we perform well? Well, depends on how we think. And there are a lot of constraints on human cognition. We have memory constraints, attentional constraints, knowledge, experience, the design of it. You know, is the task you're trying to do really difficult or counterintuitive, or those things? Counterintuitive literally means that whatever this design is against your intuition, against your cognition. Biases that you might have. Everybody's got them, and they, you know, outside of just, you know, what we think of standard bias in terms of preferences or in negative connotations, prejudices. We also have biases like we tend to think we are smarter than we are, like internally. We tend to underestimate others and overestimate ourselves. Those kind of things that are natural, that are just for some reason what humans do. And then we have our own, those I would also categorize as just kind of those generic human limitations. You know, right there, that comment kind of captures almost a recency bias or some kind of a bias there to just go with what's immediately apparent. And recency bias, you know, the bias that what is most likely to be chosen as the answer is whatever the most recent thing that you can recall is. This is that in action if you were doing it. Physical aspects of performance. So ergonomics are a big one. Strength and endurance, you are literally fitting the work to the user in the sense of the user can lift X amount of pounds, so we're going to minimize the job tasks to accommodate that or anything there. Now, sensation and perception limits. We'll get into sensation and perception on next week or the week after, probably, which is, our senses, multiple stimuli, competition between stimuli. Anybody who's tried to read and or listen to, let's say, an audiobook and write at the same time, understands that. Multitasking. We're not good at multitasking. And in the sense of multitasking is a misnomer, our brains don't actually do two things at once. Yet another great thing, we create, as human cognition, we create words for things that don't actually exist. And then they become a part of our lexicon and we start designing for things that don't exist. That's an interesting, weird shortcut we go through. Human performance in nuclear. We already went through some of these procedures and trainings, self-checks, peer checks. Corrective actions are a unique thing in kind of a lot of safety critical industries. So when something happens or something's wrong, you will issue corrective actions, which are formal. Okay, to make sure this doesn't happen again, we're going to do X, Y, and Z. And then you have a process in place for verifying that you did do those things. Questioning attitude is a big one you'll hear in safety culture and in nuclear, which is just if you don't feel right about something, trust your gut, trust your intuition about those things. The problem is it's trust your gut, trust your intuition, but also follow the procedure and don't deviate from the procedure. So it can be a lot of conflicting information. Error analysis is one that we will go into a little bit there. I mean, that second root cause analysis is a field in and of itself. And, at least here at the INL, when we get trained in root cause analysis, that's a week or 2 week long course. But FMEA, failure modes, and effect analysis is something we'll go into. Fact findings are essentially just meetings where you debrief what happened and kind of try to rebuild the timeline in that. We'll go into kind of what should be present in a fact finding if you're going to do it right. But the bottom point there, keep in mind, all of these steps are still fitting the work to the worker versus, or I actually wrote that wrong. They're still fitting the worker to the work versus the other direction. If you're trying to proceduralize and train something, my point, I would argue that your process is not intuitive enough. It is not well designed enough. And so in nuclear, I think we're still kind of stuck in that somewhat. The reality human users. So if you've ever ran a user study, you will know this, if you only had one user, you can train them, instruct them, guide them. You can get to a perfect, outside of the standard error probabilities, no human's 100% perfect, but with just one person, you could probably get it pretty close. For all users though, that doesn't work. You can't do that for each person. You have to design something that is, the best of everybody. What if a pump came to work wanting to be a valve? That's something I say to engineers sometimes to kind of get what we're doing across, because they think of it, well, a pump performs at a certain rate or under a certain load for a certain amount of time, and then it can fail. But I understand that. But what if humans are? What if the pump came to work and wasn't a pump anymore? Maybe even just for that day. That's what humans do. They are dynamic and chaotic in that sense. Someone comes to work and is going through a lot of hardship or something. Those things can have an effect, and keeping that in mind. So the design, our job as designers is to make the right choice the easy one, make the right choice or what we want to happen the main one. Then Okay, sorry about that brief break there. I had a family thing I had to attend to. So, all right, so we're back here. Uh, so yes, make the right choice, the easy one. All right. So, and keep in mind this quote from Men Black: "A person is smart, but people are not." And it's important to just recognize that and design for it. We know it, so just accept it and kind of move on. Um, this is a lot more of that. People are like water, so design for what you do or don't want. Um, we've all seen the road and then the little walking path thing, and uh, especially in you might be in an unsafe area, and then what if your sidewalks have a circuitous route, and then people cut across, but you don't want them to. Okay, well, why don't you make the path where people walk versus trying to make people walk where the path is? Um, and kind of in a more sinister angle, this is an example of a literacy test for voting that was done, back in Jim Crow days. What was the goal here? It wasn't that you needed to be literate to adequately assess candidates who would uh, respect your wishes in office. It was because of the uh, numbers of illiteracy in African American communities was high. And if you don't want them to vote, put in something that makes it hard for that group to vote. That's a design choice. Um, Unethical in that case, but it's important to realize that we can design uh, things to be harder or easier. And sometimes those decisions are based off of other motives than just success of the user. In nuclear, operating experience review is a big one that you'll go through. And essentially, what we're looking at is with operating experience review is we want to talk to people who actually operate the system. If you're creating a new system, or this will happen in consumer human factors, where you're doing a new application or program or something, where your users have never seen that before. It's never been something that they have any experience with. That's novel and has one angle on it. We're not dealing with that here. We're dealing with things where they know what is going on. An operator who's been in his or her plant for decades can see those control boards and know what's going on, and they start to gain that meta understanding of how it works. um, so that's what you want to try to capture, is that unknown, um, and to understand kind of what they're talking about, what they need, and then do our best to match that. Functional requirements analysis is another one that you will notice in nuclear comes up a lot. It's a question of automation primarily. So functional requirements analysis is often paired with function allocation. So you break out what are the functions that need to be performed, and then you start, that's the functional requirements analysis side of things. What's that function? How does it need to be performed? Is it difficult to do, or is it safety critical? Those aspects. And then, okay, how are we going to allocate that among, and your allocation is between humans or machines. Um, and as you're going through that, you will get an in-depth experience with what that scenario is or what that task you're asking them to do is. So function allocation can be a useful addition to like a task analysis, just to ensure that you caught everything. And you might come up with some other design ideas like, hey, there's really no reason why we can't automate something. In terms of human error, you should automate as much as you possibly can. Um, so while still giving transparency to that automation, but your success can be assured a little bit more. Task analysis. So here's an example of a chart from a task analysis for a drop trod scenario. So this is highly, highly specific. So don't, if you've never seen something like this before or seen it done this way, don't worry about it. But this is an example where we're looking at individuals, we're looking at scenario steps, those kind of things, and how we would assess that. The numbers on the left are essentially what we're looking at steps or along a time scale. for them. Now, task analysis, one thing to keep in mind, especially if you've been through a human factors course or a degree program or anything, task analysis is a critical part of human factors that doesn't really have a fixed method. There isn't necessarily one way to do a task analysis. It's more a philosophy or a grouping of aspects that you should capture within a task analysis. So if you feel like, hey, I went through these courses and I don't know how to do one, don't worry about it. If anybody tells you they did, they're wrong. They might have done one, but they don't know how to do task analysis as a whole, because it's not something that you can, just, oh, yes, I know how to do it. I learned the one way to do it. There are countless ways to do it. If you are having a hard time and you're in need of a method to start with, applied cognitive task analysis, or ACTA, is one that, at least in my experience, has been those methods and processes have been fairly well documented. So you can kind of plug and play and pick pieces of it if you need to. But there are a lot of other ones too. Usability testing and prototype. So this table is kind of pulled from what would be called the GO-NUC method, which was an adaptation of a nuclear regulation, New Reg 0711, in a way to try to guide design. So, but these four primary things are still critical to look at there as you develop a prototype of something and need to test it. And keep in mind, this doesn't necessarily have to be a physical or digital prototype of anything. If you're prototyping a new process, a new organizational scheme, all of these things still matter. Heuristic evaluation is essentially expert review. You're looking at, you're getting an expert in a field, they're using some method or benchmark or measuring stick thing checklist to see how your system, app, product, or thing, process identifies to that. And essentially, it means shortcut. That doesn't mean it's not effective. It is a shortcut, but we kind of defray that risk of the shortcut by bringing in experts in a defined methodology. Design verification. So this is one, New Reg 0700 is the primary style guide, I would say. It was what I would probably call it for nuclear design. It doesn't have any pictures, so it's not going to show you what something should look like. But in terms of how the nuclear industry expects color to be handled, fonts, different windows, navigation, that's what that's used for. So we do evaluate a system for conformance to New Reg 0700 or other standards. There might be a different standard in your particular field. Aerospace has its own world of standards. So does medical devices. I mean, there's a lot of those out there. So, but just make sure you are comparing your design to a standard. And also keep in mind, those standards are not necessarily set in stone. And like everything else, you can deviate from them if you have the evidence to back up why you're doing it and that it works and it makes sense and doesn't inhibit the overall goal. Usability testing, this is where we're going to start involving users. And yeah, nuclear, we're talking about bringing operators into a simulation environment, either on site. Every plant has to have a simulator in order to run, or at a place like the Human Systems Simulation Laboratory here at the INL, where we have some simulation capabilities. And we run them through scenarios and see how they perform with the old versus the new, or some of those type experiments. And yeah, this is one of my favorite graphs because it helps us not have to recruit 1 million people. You don't actually need that many people to catch most of the issues. Around 8 to 10 is the sweet spot, and you will catch the majority of your usability issues. So keep that in mind too. If you have contrary to other psychological research where you need huge sample sizes, you don't necessarily have to have that for nuclear, I guess, specifically. Integrated system validation. This is also a very nuclear thing. which is the, okay, you tested the system, the operators worked with it and they did good. Now we're going to put that system within the broader context of the plant or the simulator or the process. How do they work now? You know, it may break their continuity or their consistency that they've had for decades. So does that suddenly make it an unsafe situation? It's a really important piece there to look at, especially if you were working on implementing new changes to a system that has existed before. So this is an example of those cogs kind of filled in with how we would do that. So platform, EHSSL simulator, we can design, this says new Rego 711 and prototyping. One thing to keep in mind, new Rego 711 is an evaluation document used by regulators. You can use it as a design guidance document insofar as it tells you how you're going to be graded. So you know kind of what boxes you will need to check, but it is not design guidance explicitly. And then lastly, usability testing and integrated system validation. Ergonomics. So going into kind of ergonomics specifically, if I go through this too fast and someone's really interested in a part of this, shoot me a message or put it on the Slack, and I'll make sure when I do the follow-up video towards the end of the week, we'll go into it in more depth. Like I said, nothing against ergonomics. It's a very important. It's just not something that captures my attention a ton. So the study of how to design systems and maximize human physical performance. So this is when you will optimize or fix the design of a system or a tool or an application or a program to conform to what we know about the human body. You minimize risk of injury. Comfort and long-term health is a priority and a goal, and acquiring knowledge about the human body. In general, we are pretty good with information with ergonomics, but as work changes and different systems come about, there are always new motions and new tasks, physical tasks that people have to undergo. So our application space changes. These are just some costs. It is really significant. For example, the average shoulder injury, not a tear or anything, just a strain, can cost a work comp for an organization anywhere from $50,000 to $150,000. That's just a strain. That's no actual long-term detectable damage. So it can be really costly for these organizations. So safety is very important, aside from the ethical aspects of we don't want to kill people that just work because they go to work. We also want to make sure that we're not spending all of our revenue fixing them and making sure that they're okay in our unsafe world. And that goes into this. So this is kind of the common areas of injury and the financial investment. So it's always worthwhile, even though, you know, you look at it and sometimes an ergonomic chair might be $1,500. Well, a back strain or issues, you know, eventually if someone sits in a bad chair for long enough, they're going to have issues that you're going to have to pay for. So how do you do ergonomic evaluations? MIL standard. So the MIL standard is the big one. There's a lot of other ones, I believe. OSHA has one, and just kind of standards about humans. Any ergonomics textbook that you get should have tables in the back of common measurements, common physicality aspects. So the MIL standard is a specific one because it started around World War II, and every time somebody goes through to get processed in the military at MEPS, the military entrance processing stations, they get measured specifically in accordance with the MIL standard. So we essentially have decades and decades of measurements of men, women in high numbers. So we have a very good understanding of the distribution of the population. So, and we always want to design for that middle 70%. You know, if you're designing just a normal system, or let's say a new control room, I'm thinking bay, but that's not right, but like a new control room desk area or a new control room interface. You don't have to design for Shaquille O'Neal, but you do need to design for that middle 70% of male and female proportions to make sure that you're not going to be constantly incurring reach issues or uh, visual system problems. How far can we see? What's our viewing cone? All those things fall under ergonomics. So, and there is a fair amount of work to be done on that in nuclear. As you saw in that original picture, it's nuclear control rooms historically have been these humongous rooms with all these different indicators. Well, you need to be able to see those. You need to be able to, navigate to them, walk up to them, hit anything on the boards that you may need. So it's important to be aware of those. Static dimensions are the most common ones that you'll find in some of those tables. They'll be, when the body is in a fixed position, and they're really, really important for designing physical products, chairs, desks, those kind of things, where your user is primarily not going to be in a dynamic state. These are some examples of those. These images are very, very common in ergonomic coursework or in ergonomic textbooks. And these are really, really important to keep in mind especially when you consider diverse workforces, accessibility concerns, and aging workforces. I mean, all of those aspects will impact that. So you'll need to adjust those dimensions along those lines. There are differences there. This we talked about, you want to understand the curve and where most people are going to fit so that you can make sure your max and your min are covered. Dynamic dimensions. So these are a little bit more difficult in terms of there's not like a table you can necessarily go to, but there are kind of standard aspects of performing these things. How much, if you have this part of your body fixed, how far can you turn in a certain direction before you'll risk injury. We've already talked a little bit about this, but cumulative stress disorders are primarily where you will get a lot of those ergonomic costs before. There's a lot of those, and like I said, there's a whole class on ergonomics about these for those, but if you need, we can go into them more. Great example here of just sitting at a desk and how many different ergonomic measurements there are. And thankfully, we're standing on the shoulders of giants somewhat in that these have all been done for us. So chairs, for the most part, pretty well designed. We don't, I guess I could be wrong, but I don't expect huge changes in chair technology in the foreseeable future. And that was the last slide. I didn't even put an ending slide on there. Okay, so keep that in mind, and like I said, go on the Slack, post an area that you're interested in, a story you have. I mean, anything there that'll get the conversation going about human factors generally, human factors in nuclear, your specific experience. I always love bad designs that you've just seen in life. And this could be something like, this really isn't designed to work well for a human being or something. Sometimes I've seen tools that look like they were built for lobsters, but even like going to the DMV is a great example of a very poorly designed experience and just process. And one thing you'll find out comes out a lot in my thoughts is government service design is a huge kind of problem that I have. I really think that government services should be easier to get than, for example, say applying for a credit card or signing up for the military. Shockingly easy. Renewing my license plates, really not very easy. So that is an area that I will bring up a lot as we go into some of these. But I look forward to reading your posts, and then we'll engage there. And then, yeah, I'll have another video towards the end of the week. Sorry, this one didn't get up till Wednesday. The last 2 days were just a bit wacky. So hopefully that schedule will tighten up as we go. All right, I'll stop sharing here. And thanks for watching. And I hope your week goes great. Thanks.